Mm, 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 mm. Yeah, so you wanna know? Yeah, you wanna know? You wanna know about big numbers? Yeah, I've heard it. I've already heard it. I've heard it. I know it. I know you want it. First, we gotta start with the basics. Basics. 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, 10, 10. Then we're getting to the powers. 10 to the power 2 is 100. 10 to the power 3 is 1,000. 10 to the power 6, million. 10 to the power 9, billion. Then the threes on top. It increases by 3. It goes like this. Million, billion, trillion, quadrillion, quintillion, sextillion, septillion, octillion, nonillion, decillion. Numbers, you need to know them for school and anything other numbers. Yeah, you need to know them, and I'm teaching you big ones. Then we get to a vigintillion. It increased by 30, and instead of 10 to the power 33, 10 to the power 3. Then there's trigintillion, 10 to the power 9. Then we get to a Google, 10 to the power 100. If you write this, it would take a couple minutes. Yeah. Then we get to Googleplex, 10 to the power Google. You can't even fit it in the universe. Let's say if you wrote a number on any atom, every atom on the universe, it wouldn't even make it to a Googleplex. No, not even close. So yeah, numbers, you need to know them for school and something else. Numbers, you need to know them. That's why I'm teaching you big ones. Then we get to Googleplexy, 10 to the power Googleplex. It wouldn't even be close. Then there's Googleplexy Inthera. That isn't really real, but it's a Google. It's basically a Google to the power of Google, or 10 to the power of Googleplexy. Then we get to Graham's number, or G64. It's 3 to the power of 3, 64 times. I know, that is big, but it ends in a 1. That's all I can tell you. It is way bigger than a Googleplex, Googleplexy Inthera. Any of those. It is way bigger than anyone you know. Numbers, you need to know them for school, yeah. Numbers, you need to know them for school. That's why I'm teaching you numbers. Then we get to Rayo's number, the biggest finite. But there's also ones before this. Let's look. There's tree 3, the first function, which is basically Graham's number to the power of Graham's number. It's very big, really, really big. And before that, fast growing hierarchy. Then we get to tree 4, tree 5, then tree 3. Then we get to SSCG3. It's basically tree 3 to the power of tree 3. It is a lot, isn't it? Yeah. After SSCG3, basically SSCG3 times. Then we get to Rayo 10 to the power 100. This is the biggest finite number that is really real. But there's one between Rayo's number and infinity. So I'm telling you numbers, you need to know them, numbers, learn them in school, numbers, you need to know them. That's why I'm teaching you the biggest ones. So between Rayo and infinity, there's Oblivion. It is coined by Jonathan Bowles. Oblivion and utter oblivion are coined by Jonathan Bowles. He makes big numbers. Then we get to infinity. Then ordinal time. Before that is Aleph. No. Then there's ordinals. omega. Omega plus 1, omega times 2, omega to the power of 2. Then omega to the power of omega. Then after that, epsilon naught, zeta naught, eta naught, phi 4, phi omega, increment 2, increment Bachman Howard, omega, intrinsically, Brisingale, inaccessible mode. Then we get to the biggest, real number. Actually real. It's absolute infinity. It's after the long list of cardinals, which I'll tell you now. Inaccessible. Malo weakly compact, indescribable. Berkeley. A lot of ones after that. Strong compact. A lot more after that. 0 equals 1. There's also 10 to 13. Then after 0 equals 1, there's absolute infinity. So yeah, that is the biggest one. So, yeah, you know what we got in new number. I'm teaching you numbers. You need to know numbers. That's why